Your Hacks, and today we're going to be doing another OWASP top 10 web vulnerability video. Um, so today we're going to be doing a crypto failure. So a crypto failure is basically a crypto failure is basically the application having a weak cryptography algorithm which lets a hacker easily able to decrypt sensitive data. So basically, crypto failure is basically an application has a weak cryptography algorithm, meaning that say if there's any passwords, the way that they store the passwords hash, basically they have to make a hash and make it basically undecodable, basically kind of like that. And the application has a weak algorithm of that. So basically a weak algorithm could be like base 64, which is easily able to decode. That's basically what a weak algorithm is. Or able to, you can just guess the algorithm by looking at the numbers. You can like compile different algorithms, like say you want base 64 and SHA-256. You can do that, but a crypto failure is basically an application has only one cryptography algorithm, and is very weak, like base 64. So that's mainly what a cryptographic failure is, a crypto failure. Yeah, so this is really vulnerable because it can allow a hacker to easily able to decrypt sensitive data. So this sensitive data could be a company secret, passwords, stuff like that, card numbers and stuff like that. So we can just quickly do a demo. This video won't take that long because crypto failure is not a big thing, but it is a very vulnerable thing, and it doesn't really happen a lot, but it is considered in the OS top 10 for web vulnerabilities. So if you just want to head over to application.security and just hover over this play demo button and just click on this OS top 10 for web. And here we see loads of stuff here. Just click on weak randomness. So basically this is also kind of a crypto failure type thing. So we can just read this. It only has 8 steps, so this should be fairly simple and easy. The application. So CloudZone is a cloud hosting provider that offers virtual service for developers, startups, and enterprise customers. We can just click next. Penetration test. Alice, the CTO of Cloud City, has engaged Bob, a cybersecurity consultant, to conduct a penetration test against legacy CloudZone, a web application used to orchestrate network backups. What is a penetration testing? I can just quickly read this if you don't know what penetration testing is, but you can just click next. Okay, load application. We're loading the application right now. So as Bob, go ahead and load the CloudZone web URL application in your browser using the following URL. So this is the backup host of the CloudZone. Right, so this website is gonna back up the network data of the virtual machines. The CloudZone is meant for making virtual machines and stuff like that. So let's just hit next, and we need a login and login. So for legacy application, having Bob loaded the legacy application in this browser, Bob begins his security assessment by testing CloudZone's user authentication and password reset functionality. Note, in most applications, the self-service password reset flows relies on generating tokens for resetting a user's password. If these tokens are in a way predictable, the user's password can be reset by a malicious actor without the user acknowledging. Basically what it's saying is that Bob here goes ahead trying to click on forget password, trying to test out the password reset functionality, and there is a way to manipulate tokens and capture tokens by say if it's like in a self-service token flows relies generating. So basically if it's like a you can guess the next token depending. You can basically get the like you can reset the password by getting the token, and by with the malicious actor, you're the malicious actor, you're the hacker trying to hack in and change the user's password without the user knowing it. So we can just hit forget password and forgotten password to test the uniqueness and randomness of tokens generated by self-service password reset flow. Bob initiates multiple password resets. However, before we proceed, let's plot the token values by loading these values into a graph. So you can just hit next, and there's this graph called token, and it's gonna come up. So weak randomness as Bob initiates to 10 passwords. So we can just copy this, and we can just read this quick note here. Inspect the token values in the graph console as it plots the numerical value dependent on the time at which password request was submitted. You can see the token values by hovering the data point. So basically, a hacker can manipulate this, say, you can basically, whenever you did reset password, I'm pretty sure by the time it would basically curate your numerical token value dependent on the time at which password request. So basically, it would create your token. So this could be easy for a hacker to hack into, because then you can like predict the time and stuff like that. So if we just copy the email and just paste this, and as Bob submits your credentials at least 10 times, when you're ready, click next. Okay, so we can just click it once, and we can see it's going, and we see this here. It's hovering over it, just a random token values, but but it says here numerical depending on the time. So basically, this is something related with time. Just and then later you can just hit reset password again, and you see the big difference. So this could be, we could say, in a lifespan like basically of 10 seconds, and we see there's a difference. And if a hacker knows it's because of time, he can easily manipulate these tokens and get the token reset password token, and he can basically reset the password without the user knowing that it has been resetted. So we can just hit it 2 times, so just 8 more times. So 3, 4, 5, 6, 7, 8. Let's click on, and we see this is just going straight, because we continually spam with reset password. That's why it doesn't have a like, it has a slow increase but not that much. But we see the big difference here because we waited around the 6 seconds here, and we see there's a big difference. We can just click next, and the vulnerable code. Notice the tokens, they all have a suspicious increment pattern to them. They all seem predictable to the future. To further understand, let's see the source code in the next step. To understand the root cause of this vulnerability, let's take a look at the backend code responsible for generating password reset tokens. We can just hit analyze code. In order to allow the user to reset their password, a session token is generated that is used to identify the user. So it's going to generate the token, and it's going to take the email for it. So the email, and it's going to generate a token. The method that generates token, session token, however, does not generate a random token. Yeah, so what he's saying is it's saying it doesn't generate a random string every single time. It has something related, like time and stuff like that. So local time, get hour and minute and second. So instead it relies on the current timestamp. So it gets the hour, then it gets the minute, and then it gets a second. Basically, it's appending the local time, get the hour, and all these, and it's also gonna append the email. This leads into a weak session identifier, which could be predicted by attackers. This way, they can reset the password's victim password of the victim and thereby overtake the account. Return base64 get encoder. So I'm pretty sure this is just going to get a base64 of everything everything of this, and basically it's going to encode it. And yeah, we just hit next, and mitigation plans for this. So to effectively mitigate against the weak randomness in applications, developers should avoid writing custom cryptographic primitives and random number generators. Instead, developers should leverage their web framework or operate system cryptographic libraries, which would offer a wide variety of random number generators, functionality that are well tested and proven by cryptographic standards such as FIPS and NIST. So basically what's saying here, instead of creating your own number generators, use the web and use some famous random number generators, which have been proven by cryptographic standards and these stuff. So it kind of links how crypto failure and weak randomness is basically random number generators, and crypto failure is basically actually cryptographing like a text like in base64 and stuff like that. So this is a modified code example. We use Java's secure random class, which provides a secure p-pseudo random number generator. So this is a secure random number generator. Using the generate seed, we get a random sequence of bytes. This leads into crypto strong session. So basically it's going to just generate something random, just basically anything random, and which leads a cryptographic strong session. So it's basically harder to predict and stuff like that. So just hit next, and we can click next, and so that's basically it for today's video. And it was really fast, as I said, but you can also learn a lot about crypto failures and weak randomness. So hope you guys enjoyed, and happy new year to everyone out there. So wish you all the best, and see you guys next time. Peace.